Today we're going to be talking about lesson 9.4 in advanced math, which is choosing a data display. So a data display is a graph or a picture that helps us understand the information that we're given. So here you can see the list of data displays. At some point, you've probably seen all of these different displays. So a pictograph uses pictures to show the data. A bar graph shows data in specific categories. A circle graph shows data as parts of a whole, so these are good for fractions or percentages. A line graph shows data and how it changes over time. So as the line continues across the graph, that's how time progresses. A histogram shows frequencies of data values in intervals of the same size. So a lot of times we get histogram and bar graph mixed up. So bar graphs are for specific categories. So if you're using numbers, that would be a category for 1, a category for 2, a category for 3. Whereas a histogram might have 0 to 2, 3 to 5, and then those categories will all be the same size. Stem and leaf plot order numerical data and shows how they are distributed. So if you don't recall a stem and leaf plot, this is like we'd have data values of 10, 12, 13, and 16. This is the tens place and this is the ones place. And that's how we can organize our data in a stem and leaf plot. A box and whisker plot shows the variability of data by using set quartiles. So remember we talked about these chapter 15, I believe it was, using quartile 1, quartile 3, and the median. A dot plot shows the number of times each value occurs in a data set. So a number line with the dots above the data pieces as shown. And then a scatter plot. These are the ones that we have been using in lesson 1 and 2. It shows the relationship between two data sets by using ordered pairs in a coordinate plane. So remember, just plotting the data in the coordinate plane is a scattered plot. All right, let's take a look at how we're going to use this information. So it says choose an appropriate data display for the situation and explain your reasoning. So oftentimes there can be more than one correct answer if you give a good explanation or a good reason. So number 1, the population of the United States divided into age groups. So here we're looking at a large amount of data because we're looking at the population of the United States. We also know that the ages are divided into groups. So the best appropriate data display for this one would be histogram. So we can put that, it would be a histogram. And the reason why is we can see the number of times the ages occur. So I'm going to abbreviate here a little bit. Number of times ages occur in intervals or in groups of the same size. So remember 0 to 10, 11 to 20, 21 to 30, intervals of the same size. You can't have a group of 5 years and then a group of 15 years and then a group of 30 years. It'll skew your data or what your graph looks like. The percents of students in your school who play basketball, football, soccer, or lacrosse. So this one could kind of go a couple different ways. I know when we hear the word percents, often we think of a circle graph or a pie chart. In this case, this one we're splitting the students into 4 specific categories. So if you gave a good explanation for a circle graph or a pie chart, that would be fine. The best answer here would probably be a bar graph. So it shows the data in those 4 specific categories. Now let's take a look at a few more questions. So here it says, tell whether the data display is appropriate for representing the data in example 2 and explain your reasoning. So it says you record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits changed during the 5 months, and explain. So we're asking ourselves, would a dot plot be appropriate, or a circle graph, or a stem and leaf plot? And why or why not? So first of all, a dot plot, remember number lines. So we would have a dot at 250, a dot at 320, a dot at 485, 650, and 925. Would that dot plot show us the change over the 5 months? Since it doesn't really show us the relation of the data to the time, this answer would be no. This would not be appropriate. And we're going to just say it doesn't show change over time. Now, the next one is a circle graph. Take a minute and think about the circle graph. With that circle graph, we can label the sections by month. So we can label a section for August, a section for September, a section for October, and so on. So this could be used as a data display. And we could show these number of hits as a percent of the total number of hits for the 5 months. So we could say yes, shows percent of total for each of the months. So we would have our data on the circle graph and we would have it labeled for months so we can see the change over time. Now, the stem and leaf plot. Remember that here we might have 25 and then 0 representing 250 and 32 and 0 representing 320. Is this kind of stem and leaf plot going to show us what we need? Is it going to show us how it correlates to the time of the 5 months? So since this is not going to show us anything about that time, we're going to say no. And again, because it doesn't show the change over the time. The next thing we're going to be talking about is the display misleading? So is it tricking you to think something different than what the data is actually telling you? So take a look at number 6. So we can see here that they're selling tickets for a concert for a rock band. So 3 different rock bands. You have Group A, Group B, and Group C. And the concert ticket price in dollars. So is this display misleading? And if so, why? Take a minute and see if you can come up with why this data is misleading. So there are actually 2 reasons why number 6's graph is misleading. The first one, we can see that as the tickets get taller to go up to the higher dollar amounts, the tickets actually also get wider. So since the ticket widths change, we think that the price might change. So I'm going to say the price or value may vary. Because since they're not the same width, it kind of tricks your mind to thinking they're like exponentially larger. Now, the second reason why this data is misleading is the break in the graph. So the break in the graph is taking out some data down here, which would also kind of adjust the size of the tickets. So since, if we have this much missing out of this ticket A, that's like maybe about half. Well, when we have this ticket over here, that's just a small portion of the overall ticket. So the break in the graph also makes it misleading. Now, with number 7, take a look and see if you can identify why number 7 is misleading. Here we can see that in number 7, they're talking about the company profits over 5 years. and we're talking about billions of dollars. So we can see that over the course of these 5 years, we had about $10 billion, maybe 11, then maybe 12 and a half, and then 13, and then maybe $14 billion. So we had slow growth, but we had some growth. But when we just look at this bar graph without really taking a minute to think, the profit increase may seem larger because as we go across, the bar width changes. So as the bar grows up slightly, the width gets largely wider. So we can say that increasing bar width makes increases seem larger than they are. So it's a way to trick your mind. Now, it's important when we are, studying data in displays that we're identifying any things that might be misleading so that we're really grasping the information for what it truly is and that we're not led to believe something different than what might be true.